Hi Bobcats, this is Miss Lee, and today's lesson is on fraction, decimal, and percent equivalent benchmarks. Fraction, decimal, percent is also referred to as FDP. FDP, fraction, decimal, percent. Equivalent means that they each represent the same value. You take one value and you're just writing it in three different ways. You're writing it as a fraction, a decimal, or a percent. And benchmarks are kind of like landmarks. They're the really familiar fraction, decimal, and percent equivalents that you're going to use throughout the rest of your life. Okay, very, very common. They're the ones that you really should have memorized. And in this lesson, I'm going to show you kind of a way to think of equivalent fraction, certain equivalent fraction, decimal, and percents using money that will help you memorize them faster. Okay? All right, let's get started. Make sure you have your notes and that you're staying caught up. If you need to, pause the video. Okay, let's do a quick review of what you've learned in elementary school. You've already learned about fraction, decimal, and percent, and you learned about them with models. You use models in all three. So looking at our fraction model, you learned that you can write the shaded amount as a fraction as a part to whole, where the shaded part is 1 and the whole is 5. So 1/5 is the fraction that's being modeled. Then you went on to decimals. You know that this square equals 1 whole and that each column represents 1/10. So if 2 of the columns are shaded, that means 2/10 are shaded. If I take this decimal whole and I compare it to the fraction whole, what do you notice? They're the same size, right? And the shaded amount is the same amount. So that tells you that 1/5, the fraction 1/5, is equivalent to 2/10. And then you've learned that a percent is always out of 100. So when modeling percents, you have to have 100 little squares, and if you look at how many are shaded, there are 20 shaded. 20 out of 100. Since 20 is out of 100, we can write that as a percent, 20%. Again, I can compare my model. Here, my decimal and percent are the same. Move it over here, my fraction and my percent are the same. These three forms, they all show the same equivalent amount. So 1/5 is equivalent to 2/10, and both of them are equivalent to 20%. This is an equivalent fraction, decimal, percent. And this is what we're talking about. You're modeling, or you're showing the same amount, you're representing the same amount just in three different forms. And you need to be able to know all three different forms. If I give you 1/5, you should automatically tell me, oh, that's 2/10 or 20%. Or if I give you 20%, then you should be able to tell me what the fraction and the decimal equivalent amounts are. All right, again, we found the easiest way is to think of it in terms of money. So we're going to make sense of FDP benchmarks. Okay, 1 whole dollar. Let's break this into a fraction. Think about pennies. How many pennies make a whole dollar? Or how many cents make 1 whole dollar? 100, right? So if I write this as a fraction, the denominator would be 100 for 100 pennies. And then for it to equal 1 whole dollar, the numerator would have to be the same. It would have to be 100. And this is actually true for any fraction that has the same numerator or the same denominator. They equal 1 whole. And if we're going to talk about money, so this is the fraction form. Let's go to the decimal form. If we're going to talk about money, then just write it as money. 1 whole dollar. How do we write that? We write it like that. You could also write it as 1 0/10, or you could just write it as 1. That's fine. And then lastly, we want to write the percent amount. Again, the percent is always out of 100. Since we're talking 100 cents, that's already out of 100. So it'd be 100%. It's like eating the whole pie. You ate 100% of the pie. You get all of the questions on the test correct. You score 100%. Okay, so let's take our dollar and let's cut it into half. If you cut it into 2 pieces, you can think of it as the half dollar coin. because you need 2 half-dollar coins to make 1 whole dollar. So here's your 2. But if we're going to talk about this part here on the left side, that's just one part out of the 2. 2 is your denominator. 2 parts make the whole. And each half-dollar is how much money? Hopefully you know that it is 50 cents. You could also drop this last 0 and write it as 5/10, and it's still going to be equivalent. And then you have your percent. This is 50 cents. It's 50 cents out of 100 cents, right? And anything out of 100 you can write as a percent. So our percent would be 50%. And then if you extend this and you want the whole dollar, the fraction would be 2 out of 2. Since we're talking about half dollars, 2 is your denominator. And it's still going to equal $1 and 100%. So what if we take our halves and we cut them into halves? That's going to give us fourths. And what 4 coins make 1 whole dollar? Quarters. So 4 quarters make 1 whole dollar. So our denominator is going to be a 4. And if we're talking about this first part here, then we're only talking about 1/4 of the dollar, which this means 1/4 out of 4. Anytime you see 4 as your denominator, think quarters. This is 1/4 out of 4. And 1/4 is how much money? 25 cents. 25 cents out of 100 cents is 25%. Okay, so now we're going to shade another fourth for a total of 2/4. So we're just adding another quarter. We add another quarter, giving us 2 quarters, 2 quarters out of 4. Each quarter is 25 cents, so that would be 50 cents. And 50 cents out of 100 cents would be 50%. You might have recognized that 2/4 actually simplifies to 1/2. And then you can think of it as the half dollars, either way. Okay, let's add another quarter. We now have 3/4 of our dollar. 3 quarters out of 4, 3 quarters is 75 cents. 75 cents out of 100 cents is 75%. And then of course if you add another quarter, then you have your whole dollar. 4 quarters out of 4 make a whole dollar, which is your 100%. What happens if I take my fourths and I cut them into half? What do we get? We get 8 parts, don't we? But there are no 8 coins that equal a whole dollar, are there? No. Okay, so let's think about it. 1/4 is a quarter, or 25 cents. But we've cut it into half. So we need to cut our 25 cents into half. So what is 25 divided by 2? Does anybody know? I'm going to move over here while you're thinking about that. $0.25 divided by 2 is going to be 12.5 cents. 12.5 cents, which as a decimal is written as 125 thousandths. And this 12.5 cents out of 100 cents equals 12.5%. You can write that as the percent. So every eighth, it's 1 shaded out of 8, every eighth is equivalent to 125 thousandths, which equals, I'm going to move it up here, 12.5%. Because it's half of a quarter, half of 25 cents is 12.5 cents. Okay, so what happens if I shade another one? I don't have a square here, but if I have 1/8 and I add another 8 for 2/8, 2/8, simplify that, equals 1/4. And you should know what that is. 1/4 is 1/4, which is 25 cents, 25%. Okay, let's add another 8th. We now have 3/8. No, it doesn't simplify. But you need to think of 3/8 as saying 3 of the 125s. So 125 plus 125 is 250. You can run a total over here. 125 plus 125 is going to be 250. Let's add another 125, and it's going to give us 375. So it's going to be 375 thousandths, which is 37.5%. If we add another eighth, it's going to give us 4/8. And 4/8 you should recognize as simplifying to 1/2. And you know 1/2 is going to be 50 cents or 50%. If we add another eighth, we're going to get 5/8. So let me add another 125 over here where we got the 500. And now we can add one more for the 5/8. And it's going to give us 625 thousandths, or 62.5%. If we were to add another eighth, it would give us 6/8, which simplifies to 3/4. 3/4 out of 4 is how much money? 75 cents, 75%. And then add another eighth, and that's going to give you 7/8. So if I come back over here, add 125, that's going to give me 750. So let's add another 125. We get 875 thousandths. Or think of this as 875,000 cents out of 100, which would be as a percent, 87.5%. Then if I were to shade the whole dollar, then I would have shaded 8 out of 8. So how many half quarters will make $1? Well, 1/8 is half quarter, and there are 8 parts, so it would be 8. I think the tenths are probably the most easiest. Tenths, think of dimes. 10 dimes will make $1. So if we shade one part, we've shaded 1/10. Think of having 1 dime. Writing it as a decimal, 1 dime is 10 cents. 10 cents out of 100 cents will equal 100%. Now, I don't have a row for 2/10 because 2/10 is 20 cents. Every time you add a tenth, you're just adding a dime. Here we have 3. This covers 3 rows, so it covers 3/10, which is a money. 3 dimes is 30 cents. Or you could just write it as 0.3, that's fine. 30 cents out of 100 cents would be 30%, because percent's always out of 100. What comes after 30 cents? 40 cents. After 40 cents, 50 cents. So this would be 5/10, which is equivalent to 5 dimes, 50 cents. 50 cents out of 100 cents would be 50%. Add another dime and you would get 6/10. Add another dime, you get 7/10. 7 dimes equals 70 cents. Or you can write it as 7/10. 70 cents out of 100 cents would be 70%. Add another dime and you get 80 cents, or 8 out of 10. Add another dime, it's going to give you 9 dimes, 9 out of 10. 9 dimes is 90 cents, or you could write it as 9/10. 90 cents out of 100 cents would be 90%. And the last one I want to talk about is the thirds. Okay, there are no 3 coins that make up $1. The thirds are a special case that you're going to see a lot. So it's important that you have them memorized. And I'm just going to help you out here. 1/3. My dollars cut into 3 equal parts. If I shade one of them, I have the fraction 1/3. Remember, this division bar, or this fraction bar right here, it means to divide. So I'm going to divide 1 divided by 3. And you actually learned in 5th grade that if you have a whole number divisor, you could add a decimal and bring it up and a 0, and you can keep dividing. So 3 doesn't go into 1, but when I added the 0, 3 goes into 10 3 times. And 3 times 3 is 9, subtract 1 remainder. So I can add another 0 and bring it down. And I get 10. 3 goes into 10 3 times. 3 times 3 is 9, subtract 1 remainder. So I could add another 0, bring it down. I have 10. 3 goes into 10 3 times. Do you see what's happening? The 3 is repeating over and over and over again. And that's what's special about the thirds. This 3 keeps repeating. So to write it as a decimal, we're going to write it in money format, since we're talking about money. It's going to be 33 cents, but it's not exactly 33 cents. It's actually 0.333333333333333. The 3 goes on and on and on and on. And the way to write that is we put a bar over the 3, a repeat bar. So when you see that, it means this 3 keeps repeating. Now, you could also write it like this. 3/10 repeating, 33/100 repeating. Sometimes you'll see it like this. But I would go with one of the first 2 forms here. And then to write it as a percent, it's really special. It's going to be 33.3 repeating percent. Let me write it up here. 33.3 repeating percent. If you come back over here to our division, is there a whole number 3 here that's repeating? No. What's repeating is the decimal value. So if you were to write 33% and put the repeat bar, that would not be correct. Your ones place cannot repeat. What's repeating is the 3 and the decimal place values. So you have to have this decimal value, 3 with the repeat bar. Or you could write it as 33 1/3%. You're going to see it both ways. You need to know both ways. Okay, what if I add another third? I have now shaded 2/3. Well, if 1/3 was repeating 3s, and I'm adding another third, repeating 3 plus repeating 3 is going to equal repeating 6s. And as a percent, 66.6 repeating percent, or you could write it as 66 2/3%. And then you know that 3 out of 3 is 1 whole. Okay, so hopefully thinking about this in terms of money will help you easily come up with the equivalent fraction, decimal, percent amounts for these benchmarks. This is something you do need to memorize, so I suggest you make note cards or make a list and go through it and kind of quiz yourself on it, or have your parents quiz you on it to see if you can get them memorized. Okay, nice job. Thank you.